Okay, in this lesson, what we're going to be doing is using the Pythagorean relationship to solve for the lengths of an unknown side for a right triangle. So, there's two questions that we're going to be doing and investigating. Before we do that, just this triangle here should look familiar to you, and what we learned was something about the areas on each side of a right triangle. What we actually learned here, which I will write in purple, is that a squared, so the area of this small square on each leg, if you add them up, equals up to the area of the square on the hypotenuse. So a squared plus b squared is equal to c squared. So we can use the Pythagorean relationship to determine the following. And one thing we can do is to determine the length of the hypotenuse. The hypotenuse of a right triangle is the long side of the right triangle. It's always opposite the right angle. So c squared, that's the hypotenuse here. So we can use the Pythagorean relationship to solve for the length of the hypotenuse of a right triangle. So let's jump straight into an example. So this first example here says, determine the length of C. There's two methods we could use. One is a diagram and one is just use the numbers. It's totally up to you. But in this particular question here, do not give me an answer of 5 plus 12 is equal to 17, because there's no way that that diagonal length of C could be equivalent to these two perpendicular lines here. So remember, the relationship is a squared plus b squared equals c squared. So if you're using a diagram, what you'd want to do here is draw the picture with the squares on it. So we know that these two small squares adds up to the area of this big square. Now, in this particular question, these generally take 4 steps. So to find out this area here, it's 12 times 12, which is 144 centimeters squared. The area of the green square is 5 times 5, which is 25 centimeters squared. So that tells us that the area of the large square is 144 plus 25, because we have to add up the two smaller squares to get the larger square, and that's 169 centimeters squared. Now the issue here, and we learned this in section 3.1 and 3.3, is how to get the side length from the area. In order to get the side length from the area, you should recall that we take the square root. So if the area is 169 centimeters squared, then that length is going to be the square root of 169, and that's equal to 13 centimeters. So that's the final answer. Now if you're just using the numbers, you could do the exact same question without having to draw the pictures, and maybe I'll do something similar to that in the next question, but it's the same idea. It should take 4 steps. So 5 times 5 is 25 centimeters squared. 12 times 12 to get the area is 144 centimeters squared. The third step would be adding those two smaller areas, so 25 plus 144 is equivalent to 169 centimeters squared, and then the final step would be to take the square root of 169, which is 13 centimeters. So that's how we can use just numbers or a diagram to solve for the length of the hypotenuse. Now the second scenario in this section is we can use the Pythagorean relationship to solve for the length of a leg, which is one of the shorter sides of a right triangle. So in this question, if you're looking at this particular question and writing it down, what you're going to see is it says determine the length of D to 1 decimal place, is that D is not the longest side of this right triangle. So in this particular case, there's one thing that's going to be different, but the answer is not 10 minus 5. The answer has to do with the areas of the squares on each side. So if you're using the diagram, and then I'll jump into the numbers here in a second, the diagram suggests that that large area minus the smaller area is going to equal the area of the square where D is. So if you're doing the numbers, let me show you how they work in both cases. The first thing you're going to have to do in both cases is find out the large area. So 10 times 10 is 100 centimeters squared. Or in other words, 10 times 10, this area is 100 centimeters squared. The second step is going to be to find the area of the smaller square, which is going to be 25 centimeters squared. So 5 times 5 is equal to 25 centimeters squared. And here's the difference between this question and the previous question. In this question, you're solving for the area of this smaller square. So instead of adding the two areas, you're going to be subtracting them. So it's going to be 100 minus, so the large area minus the smaller area to give us that area. So 100 minus 25 is equivalent to 75 centimeters squared. That's the area of this particular square. And again, to get the side length, as you saw in the previous example, you're going to take the square root of that area, so the square root of 75. And the square root of 75 is, in this question, since it's not a perfect square, will be a decimal number, so I'm going to take the square root of 75, and that is 8.66. So if it wants one decimal place, it's going to be 8.7 because that 6 rounds up to a 7. Sorry. So that's how this particular question is going to be approached. So that is going to be 8.7 centimeters. 8.7 centimeters. And there we go.